Hi everyone, myself Bidyutlata Sahoo, Assistant Professor in the Department of CSC, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. This is my 14th video lecture on the subject Applied Artificial Intelligence. Already I have discussed almost 13 videos on this course. Today I am going to discuss about the knowledge representation using semantic networks. These are the topics to be discussed. The first one is techniques of knowledge representation. I will introduce what are the techniques. Anyways, today I'll discuss only one technique, that is semantic network representation. This is the topic learning outcome for this topic. After the completion of the topic, students can understand and they can discuss the structure of the semantic networks in knowledge representation to represent relationship between the objects, attributes and concepts. Let me discuss about what are the various techniques of knowledge representation. Why knowledge, what is knowledge, and why the knowledge representation is required. Already I have discussed in my previous video. If you want, you can watch my previous videos. So there are various almost 4 techniques are there for the knowledge representation. The first one is logical representation, then second one semantic network representation, third one frame representation, and fourth one production rules. So the logical representation, the second one, actually in today's topic I'll discuss the second one regarding the semantic network representation. But let me introduce what is the meaning of logical representation. So logical representation means the knowledge which can be represented logically, means by using few some rules, logical rules. So especially in the logical representation, it is used to derive the valid conclusion from a set of premises. So, but the problem is in the logical representation, the inference, and it is very difficult for the user for the representation because many symbols are there. It is difficult for the user to remember and to understand, and it does not provide like what human thinks. The similar kind of representation we cannot represent in case of logical representation, as we have already known that there are 2 types of logical representation. One is proposition logic, another one is predicate logic. Especially in proposition logic, if you consider we used to use various connectives like the disjunction, conjunction symbol, implication, double implication symbol, even negation. These are the symbols we used to use in the proposition logic. And in predicate logic, along with these symbols, we used to use 2 more quantifiers, that is universal quantifiers and existential quantifiers. So all these symbols are very difficult for the user to represent our natural language. So that is why to overcome this problem, we'll go for the semantic network representation. So semantic networks, there are 2 words I want to introduce here. What is the meaning of this semantic and what is the meaning of network? So semantic means the meaningful. In logical representation, actually it consists of syntax as well as semantic. Syntax means which consists of rules. Based upon the rules, the representation will be done. And it adds some few meanings also, but it is difficult for the user to represent. That is why semantic network representation came into the picture. Semantic means the meaningful, network, connected meaningful information which can be represented with the help of graph. That is the meaning of semantic network representation. So here this is the alternative of predicate logic for knowledge representation. So in semantic networks, we can represent our knowledge in the form of graphical networks, in the form of graph. So because graph is very simple and it is very easy to understand the knowledge. So that is why it uses the graph for the representation of knowledge. Now we will understand how the graph will be created and how the nodes will be created. Now, in semantic network, the information is represented as a set of nodes connected to each other by a set of labeled arcs which represent the relationship among them. So as it is a graph, it can be represented with the help of nodes. The node you can represent with the help of ellipse or with the help of rectangular box as you like. So these are called as the nodes. So and every there may be various nodes in a particular network, and the nodes can be interconnected or connected with the help of some arcs. Arcs can be represented with the help of this arrow mark, and every arrow mark should be labeled with some name that represents the relationship. This is nothing but the relationship between the nodes, right? So this is the node 1 and node 2. Now which one we need to consider as a node, that I will discuss. Now, so in the graph, in semantic network representation, nodes represent the object and descriptive information about those object. So that object, it may be any entities or any attributes or any states or events. Now, what is the meaning of an entity here? How we can consider from a sentence which one is the entity or which one is the class or which one is the object. So entity, for example, a paragraph is related to student, then we can say it is the student is the entity. If it is related to college, then we can say college is also an entity. If it is related to some characteristics of an entity, then we can say these are the attributes. Okay, so like this we have to consider. So object, maybe the car, maybe one object, book is an object. So we have to consider the object, their descriptive information about the object. Even we can consider the class, subclass also. So everything is considered as a node in semantic network. Then come into the picture. Next one is the links. Links is nothing but which describes the relationship between the nodes, and levels which we specify over the link that indicates the type of relationship. Now here the relationship is bit different. I will discuss after a few minutes. Now object can be any physical item. Now object can be a car, or it can be a book, or it can be a desk, or even a person we can consider as an object. Object can also be concepts, events, and actions. Concepts means the class. It can be considered as a class also. Class, subclass, events, and the action performed by the event, that can be considered as an object. Now, attribute of the object can also be used as the node. I will show you the diagram with the help of example. So this may be the attribute, means what are the characteristics of the object. The characteristics may be size or the color or the class or the age. These are the attributes. Attributes can also be considered as a node. Now we have to find out how these object or the class and their attributes are related with the help of relationship in the form of graph. Now, semantic networks are very easy to understand and can easily be extended. But definitely, as like especially the semantic network, it can interpret or we can represent the knowledge how human being thinks exactly as it is. We can represent in the form of graph. That is why a layman without the knowledge of AI also he or she can understand, and it can be easily extended. That means if suppose some other new information comes, then also we can add that information into the existing graph. That is why it can be easily extended. Even suppose, for example, some knowledge is updated, some like existing knowledge is deleted and new information is added. That is also possible in case of the semantic network. So that is why it is called as it is easy to understand and can be easily extended. And this representation consists of mainly two types of relations coming into the, because as I told, everything can be represented in the form of node, here also in the form of node, and node can be connected with the help of arc, and arc should be leveled with some relationship. Now this relationship can be of two types. One is a relation and second one is kind of relation. Apart from these two also, one more relation is there, instance relation. I will let you know. So is a relation is nothing but the inheritance. Inheritance, as we know that the subclass always inherit all the properties of the parent class. That is called as the concept of inheritance. So whenever the inheritance exists, then we can write the relation. Now the link between these two we can write is a relation. Okay, and second one is kind of it is a kind of relation, but it does not support inheritance, but partially it supports inheritance. That means the subclass does not inherit all the properties of the parent class. It inherits, but partially it inherits the properties from the superclass. Then in that case we can write the kind of relation, or we can write the instance of also we can write. Okay, now we'll see one of the example of easy relationship. The easy relationship is used to represent inheritance in a hierarchy. It connects a subclass to a pair superclass. So subclass is called as the child class and superclass is called as the parent class. Now you see the example, dog is a animal. Here we will not see the like alphabet A is there while write N. No, is N I cannot write here because the relationship is A. Grammatical mistake doesn't matter. So here dog is a animal. So what is the relation here? Is A. That means we can represent here the dog we can write down and animal I'll write at the up. This is animal. So dog inherits all the properties from animal, right? So dog is the subclass and animal is the generic class, which is called as the superclass. Always in inheritance, dog inherits each and every property of the superclass. This is superclass. This is superclass and this is subclass, right? So dog inherits all the properties of the animal. So in that case, we can mention the relationship is A. So how we can represent in the form of graph? If dog is one node, animal is one node. Now here I'll write dog and here we will write animal. Then we can create and here I will write is A. Like this we have to represent. One of the sentence we have represented using semantic network. So like this, if we have n number of statements like this, we have to find out which one is the subclass, which one is the superclass, and what is the relationship exists. Based on that, we have to create the graph. Now, this is one of the relation which is called as easy. Second one is kind of relationship. The kind of relation is used to represent the category membership or classification. It does not represent inheritance completely. It is used to represent category membership. So it is similar to the easy relation, but it is more commonly used for categorization rather than strict inheritance. Now we can see the example, rose kind of flower. Okay, so rose is a kind of flower. Rose does not inherit all the properties of the flower. It is an, or else you can write instead of kind of, we can write instance. Okay, instance relation. So rose is a kind of flower. So it does not, rose does not inherit all the properties of the flower. Partially it inherits all the properties from, partially it inherits the properties of the flower. That is why it is a kind of relationship or it is a category membership, because especially it is used for all the examples or the instance. Now we'll see with the help of example, we will understand how to represent the semantic network. This is the first example. Let us see what are the total 6 statements are there. First statement is Jerry is a cat. Jerry is a mammal. Jerry is owned by J. Jerry is white colored. All mammals are animal. Jerry likes cheese. How to represent? Now in this, if you find in this all these 6 statements, Jerry is a class, okay, and we can take, and cat is also a class. Yes, Jerry is common almost in all the sentences. Now Jerry is a mammal, so every time in all the statements Jerry is repeating, we should use only one node for Jerry. No need to repeat for 6 times or 100 times. So Jerry is mammal, so Jerry is one node. Cat can be one node, mammal can be one node, because these are the classes. Then we will define which one is the subclass and which one is the superclass. That depends upon the type of sentence or who can be the subclass and who can be the superclass. Now Jerry, what here you can observe, Jerry is a cat, so is a relation. Jerry is a mammal, relation is a. Jerry is owned by J. So J is one class, Jerry is already there. Is owned by is the relation is owned by. See, you might be thinking now I'm saying there are two kinds of relation, is and kind of. Apart from that, so many relations we can build that depends upon the user's context, who is creating the graph. That depends upon the statement also. Now I cannot write is a J. So, okay, instead of is owned by, I cannot write is a or instance. So, is owned by means the same as it is relation, we have to mention over the R. Now, Jerry is white colored. What is the property here? Jerry is the class, white is one class, colored is the property. Which color? White color. All mammals are animal. Already, okay, mammal is one class, mammal is class, animal is also one class. Jerry likes cheese. Jerry and cheese all are class. Likes is the likes is the level, or it is the relation. All mammals are animal. R instead of each we can write is a. Instead of R we can write is a. Each mammal is an animal. So R here plural it is given. You can write is a also. Now we will see how to represent the representation of the graph here. You can see the picture here. Now Jerry, if you see the first statement, what is given? Jerry is a cat. Now you can see here Jerry is a cat. So here the relation is a. Same thing, the second statement is Jerry is a mammal. Because cat is a mammal, we can know. So Jerry is a mammal. Instead of creating another arc here, so we can create cat is a mammal. So that if A is equal to B is equal to C, then A is equal to C. So cat is a mammal means Jerry is a mammal. Indirectly we can say Jerry is a mammal, right? So this is done. Next one is, next one is Jerry is owned by J. So where is J? Jerry is already we have created. Is owned by J. J is one class here we have created. Then previous one, next one is Jerry is white colored. Now Jerry and white. Jerry is already we have it is exist, and white is also one class. Is colored is the property. Jerry likes cheese. Here likes is the relationship. Is colored is the relationship. Cat is a mammal is the relationship. Mammal is a animal. All mammals are animal. It is given in the statement. So here all we cannot represent as we represent in our predicate logic. For all we used to write for this existential quantifier. Sorry, universal quantifier. It is very difficult to represent here. So here we don't consider all, or for some those things we cannot consider. We have to write using only these relations apart from which are common in the sentences. Now mammal is an animal. So is a relation. So like this we can build the graph. It is very, if you see the if this graph, it is very easy to understand. In each sentence you have to find what are the classes, what are the subclasses. Actually in this example there is only one attribute is there, that is Jerry is colored white. So instead of this bold red color line, you can create like this also. In so many websites and in the textbook also I have seen, you can write instead of this bold arrow mark, you can create the dotted arrow mark. Okay, because it is the attribute, so that we can differentiate which one is the attribute and which one is the class and which one is the subclass. Okay, so Jerry is a cat, Jerry likes cheese, Jerry is a mammal, and all mammals are animal. Jerry is owned by J, and Jerry is white colored, right? So this is the way representation of all the statements. Now we'll go for another example to get the clarity, more clarity. This is the second example. These are the statements. Tom is a cat. Tom caught a bird. Tom is owned by John. Tom is ginger in color. Cats like ice cream. Sorry, cats like cream. The cat sat on the mat. A cat is a mammal. A bird is an animal. All mammals are animals and mammals have food. So how we can represent all these statements in the form of network? You see the diagram here. So cat is a mammal here. Cat is a mammal. So the relationship is A. Now cat sat on the mat. What is the relation? Sat on. Now cat like cream. So like is the relation between cream and cat. Now cat, if Tom is a cat, now you see, you can this is very important. One thing, let me tell you here, the arrow mark, how you have to put the arrow mark from which node to which other node. Now if you see the example here, Tom is a cat, so Tom is a cat means what? So Tom inherits all the properties of the cats. That means Tom is the subclass, and Tom is the subclass and cat is the superclass. That we have to think where we have how to put this arrow mark. So always the arrow mark should be from subclass to the superclass. So here cat is the superclass, cat is the superclass, and Tom is the subclass, right? So based on this, we have to put the arrow mark. Now we can see cat sat on mat, cat likes cream. Now Tom caught bird, and Tom is owned by John. So is owned by is the property here, caught is the property. Tom is ginger in color. So is colored is the property here. Is colored is the property. Ginger is the node. We can say Tom is colored. Tom is ginger in color. Now mammals have food, or have mammals have. Here you can write has. Then mammal is an animal. So mammal is an animal. This is the property. And bird is an animal. Okay, animal is a bird. We cannot write in our statement. It is given that a bird is an animal. So the direction should be from bird to animal. So bird to animal. So bird is a animal, right? So this is the way we can represent. Now if you consider the attributes in all the statements, mammals has food. So food is an attribute of the mammal. So instead of this bold arrow mark, you can keep. Do not get confused, because in the textbook, in other websites also I have seen, either you can draw this bold arrow mark, or else you can give with a dotted symbol also. Better to represent with dotted symbol, especially for the attributes. But if only for class and subclass or object or event, you can give the bold arrow marks. Okay, now you can see Tom is colored ginger. This is one of the property, right? So you can make it as dotted line. Wherever you find any property or attribute, that you can convert, instead of the bold arrow mark, you can keep the, or you can give this dotted arrow marks. One more example I will explain, so that it will be clear. Every time I'm saying the dotted arrow marks we can give, but here we will see with the help of dotted arrow marks. Okay, this is one more example here, which I have taken from the Saros Kosik book. Those who are following, you can find out. Okay, so let me read out all the sentences. Here the first sentence is, every human, animal and birds are living things who can breathe and eat. So every human, animal and birds, these are three different classes which are living things who can breathe and eat. So these two are properties. One is breathe and eat. All birds can fly. So birds is one class and they can fly. Fly is one of the property of the bird class. Every man and woman are human. That means man and woman, two classes. Human, already one class you will create in the first statement itself, who have two legs. Two legs is the property. Now a cat has four. Cat is a class. Four is the property, and is an animal. Animal is a class. Four is the property. All animals have skin. Animal is the class. Skin is the property, and can move. Move also, it is the property of every animal. They have skin and they can move. Okay, they have two legs. Birds can fly. These are properties. Now a giraffe is an animal. So giraffe is a class. Animal is a class and has long legs. Long legs is the property and is tall. Long legs, tall. These are two properties. A parrot is a bird. Parrot is an instance of bird. So these are two classes you can create, and is green in color. So in color, this is the property. Color. John is a man. So John is a class and man is also a class. So all these things we have to represent with the help of semantic network, like with the dotted nodes and the arrow marks and dotted arrow marks for all the attributes and class and subclass. Now we'll see. Now you can see here As per the first statement, every human, animal, and birds are living things who can breathe and eat. Now, you see human here at this stage, human, birds, animal. All the three are these three, human, birds, and animal, comes under living things. So that is why you can observe here human, birds, and animal, these are subclass, and living thing is the superclass of the generic class. And every living things, they can eat and they can breathe. You can see the dotted line, can eat and can breathe. So these are two attributes. So as I told, attributes can be represented with a dotted arrow mark here and this one. Okay, dotted arrow mark. Now in the second statement, it is given all birds can fly. Come to bird. Okay, the second one, bird can fly. So again, fly is the property. Bird can fly. So arrow mark is from bird to fly. Third statement is every man and woman are human who have two legs. Every man and woman means both man and woman comes under human, right? So man is a human, woman is also a human. Every man and human have two legs. So two legs, it is not represented. You can, if you want, you can represent like this, legs. Okay, legs you can represent here, you can represent. Okay, but it is not mandatory here to represent. Okay, so but man and woman, as these are two classes which comes under human, so that is why man and man and woman you have to represent as the subclass. Is a relationship is a. Next one is a cat has fur and is an animal. So where is the cat? Because cat is an animal first. First we have to represent cat is a animal. This one. After that, cat has fur. So cat, from the cat, the dotted arrow marks, it comes. It has fur. Has is the relation and is the property. It has fur is the property. So that is why dotted arrow mark. Next one is all animals have skin and can move. All animals have skin. So all animals have skin means every animal has skin and animal can move. So two properties, okay, skin and move. Next one is a giraffe is an animal. Where is giraffe? So giraffe is an animal. Now one animal already created cat, one more animal. Giraffe is an animal. First we have to create. Giraffe is the subclass. Animal is the superclass because giraffe inherits all the properties of the superclass animal. Now giraffe has what is given? A giraffe is an animal and has long legs and is tall. So giraffe has long legs and giraffe height is tall. So height is the property and has is the property. Here has is the property, can is the property. But what is the attribute here? Skin and move. These are the attribute. Fur is the attribute here. Long legs is the attribute. Tall is the attribute. But over the arrow mark, whatever it is visible, these are the relation. So height is the relation. Giraffe height is tall. Giraffe height has long legs. Similarly, human has two legs. So how you can write here? Every human being has two legs. You can write here two legs. So like this we can represent. Next one, a parrot is a bird and is green in color. So parrot is a bird. So parrot is an instance of bird. Or else you can write parrot is a bird. That is also not wrong, but better to write instance because parrot is an example of bird. So parrot may not inherit all the properties of bird, but it is an example of bird. Partially, it inherits all the properties of the bird. Now, parrot color is green. So, color is the relation and green is the attribute. Next, the last one, John is a man. So, man, where we have created here, man is a subclass, comes under human being. Now, John is a man. So, from John to man, you have to give the arrow mark. That means John is an instance of man. John may not inherit all the properties of man. So, that is why instance means example of man. So, like this, we have to create the semantic network, which is very easy for the user to understand because as we speak the language in English, the same way we can represent on the paper also. So let me discuss some advantages of semantic network. Semantic networks are a natural representation of the knowledge because it interprets the human communication or human knowledge representation in the form of graph. Semantic networks convey the meaning in a transparent manner. It is very easy to understand also and are very simple. And but there are still some disadvantages are there. Semantic networks take more computational time. Why it takes more computational time? Because at the runtime, if we need to traverse the complex network free to answer some questions, again it takes lots of time to go back to the parent class. So that is why the computational time will be more, because reversing of any graph, it takes lot of time, first thing. Second one is that these type of representations are inadequate as they do not have any equivalent quantifiers. As I told, like if we cannot represent for all or for some or none, these things we can represent in case of like for all, the universal quantifier or existential quantifier as we use in the predicate logic, it is not possible to represent in the form of graph. That is one of the problem in semantic network. And semantic networks do not have any standard definition for the link names. Like whenever we use to represent the relation that depends upon the sentence, like is, a, and kind of, for instance, these are common which are already mentioned for semantic network. But other than this, like we can write the color, we can write the height, we can write likes, we can write anything that depends upon the context of the sentence. Based upon the sentence relationship, we can represent over the arrow mark. So there is no specific standard definition for the link names, and these networks are not intelligent and depends upon the creator of the system. So anybody can, those who have basic knowledge of understanding English also, they can create this type of graph. So that is why these graphs are not intelligent. So this is what I thought. We'll discuss about this, the knowledge representation of this using semantic networks. Next class, I will discuss about the knowledge representation using frames, and these are the references I have followed for the preparation of this video, especially the Soros book. And this example already I have discussed. This example is given in the Soros book, and few YouTube and few websites I have followed. You can follow it. I hope you might have enjoyed this video. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.